Hey, it's Zane Khan from Chem 1412, section number 62430. Today we will be doing lab experiment number 7, determination of the acetic acid concentration in a vinegar using titration. So before we do any of the experiments, it's always good to look into the experiment, to look into why we're doing it and how we're doing it, and yeah, so let's go ahead and look at the background of the experiment. So vinegar, obviously, it's a common household item. It's a widely used preservative. It's a cleaning product, a cooking ingredient. It's also a solution of acetic acid. Different types of vinegar are produced through the fermentation of a wide variety of fruits and grains. Distilled white vinegar is produced by the fermentation of alcohol derived mainly from corn. A titration, which what we're going to do in the experiment, is a precise addition of a solution of known concentration and composition, called the titrant, to a solution of unknown concentration or composition, called the analyst. So there's a titrant, and there's also the analyte. So in this acid-base titration, the titrant is the sodium hydroxide, which is right here, and which is delivered through a syringe in order to precisely measure. Because in the titration experiment, being precise with your measurements is extremely important, because the different, even like 0.1 or 1 ml could make a big difference, even though 1 ml is barely anything. But acetic acid is a weak acid, and it can be neutralized with a strong base, such as sodium hydroxide, and as I said before, that's what we're going to be using. And the concentration of acetic acid, which is the analyte, in vinegar can be determined through the whole acid-base titration, and that's the whole experiment we're doing today. So there's also a couple terms that are good to remember in this experiment. There's the equivalence point of a titration, and that pretty much is the moles of acid exactly equal the moles of the base. So the moles of both of the acid and the base are equal. And the endpoint is also a very good term. It's the experiment estimate of the equivalence point, and is typically identified by a color change in the indicator solution. And so yeah, let's go ahead, look at the materials needed. So we need a 10 ml syringe. We got that right over here. 10 ml graduated cylinder. 25 ml Erlenmeyer flask. We have our wonderful electric balance right here. Oops. But yeah, our electric balance is right over here. Yeah. We have our disposable pipette. We have a plastic cup. We have the vinegar, which we were talking about in the beginning, in the background. We have the phenolphthalein indicator solution. We also have our sodium hydroxide. We have our plain sheet of white paper, which I just dropped. We have our plain white paper right here. And we also, I've already poured out some vinegar into this cup right here, because we need a sample of vinegar. And it has a very strong scent, but let's go ahead and let's look at it. So I also have my apron, goggles, gloves. I also have my hat on because my hair gets in the way, so all these safety and things are good to go. So we're gonna get the 10 ml cylinder and the electric balance. We're gonna tear the balance. Okay. And then we're gonna dispense 5 ml of vinegar. It would be good if I can. got 5 ml right there. Very important to be precise as we're doing a titration experiment and everything is good. And sometimes if you have too much of the liquid, you can always get your syringe and take it out. Put it here. So yeah, so now we have 5 ml of the vinegar and record the mass. Put it on my laptop. So we got that. Transfer the vinegar into a clean 25 ml flask. And then we're going to go ahead, add 2 drops of the phenolphthalein solution. This is 2 drops only. And then transfer approximately 10 ml of the sodium hydroxide to a small cup. The solution will be used to fill the syringe. Got approximately 10 ml of sodium hydroxide. Here is the small cup. And then we're going to get the 10 ml syringe. Make sure I get everything right here. Okay. Got everything right here, the 10 ml syringe. And I'll go ahead and I'll finish the experiment up and I'll see you guys later.